Hi guys, in this video we'll be doing another machine learning project called rock versus mine prediction. So let's say there is a submarine under ocean and it has to predict whether there is any rock or there is any mine. How? With the help of this ultrasound actually. So it will release the ultrasound and it will receive some data. Based on this data parameter, it has to predict whether it's a rock or whether it's a mine. Now for this, we'll be using some sensor data. We call it as a sonar data. I'll tell you from where you will get the data. So first of all, let's see the workflow, how we are going to solve the problem statement. So guys, this is the workflow. First of all, we'll be getting the sonar data. Then we have to do some data preprocessing step. Then after that, we'll be performing tentative split operation. Then we'll be training one logistic regression model. Okay, you can use any kinds of, let's say, model here. So it's a classification problem statement. So here you have to predict whether it's a mine or whether it's a rock. So logistic regression is a classification algorithm. You can use any kinds of classification algorithm here. Then once I train the model, then we'll be using the training model to perform the prediction on top of the new data. So user will pass the new data, new sensor data, and this model will predict whether this is a rock or it's a mine. Okay, so this should be our prediction. So let's start the development. So for this, what I will do guys, I will open up my Google Colab. So there will be doing all the coding. And if you want to convert this project as an end-to-end pipeline, guys, I already have taken two actually project there. I showed you in the entire pipeline how to create. Even I also showed you how you can integrate the MLOps tool. If you want, you can also update the project with respect to that. So guys, let's start the development. So here we'll be performing the entire notebook experiment. That means everything we'll be doing in the Jupyter notebook, and we'll try to train the model, and we'll also do the prediction of the model. So guys, here you can see this is the data we'll be using. So this is actually sensor data. The name of the data is sonar data. This data is also available over the like Kaggle website. If you search on Kaggle, we'll also get the data. So what I have done guys, I have already downloaded from the Kaggle and uploaded it in my Google Drive. So this is the link. I'll share the link. From there you can download the data. So let's open up our Google Colab. So to open up the Google Colab, just try to search colab.research.google.com and just try to open it up and create a new notebook here. So now just try to name the notebook. I'll give, let's say, rock versus mine. So now let's connect the notebook. So after that, what we have to do guys, we have to upload our data. Just try to click on upload button, and this is the data. Let's upload it here. So you have to download it guys first of all, then you have to upload it here. So let me import some necessary libraries. So I'm going to import NumPy as np. Then I need Pandas. From Pandas as pd, and I also need tentative split to perform the tentative split operation from scikit-learn. So scikit-learn dot model selection import tentative split. Okay. Then I also need something called logistic regression. So from scikit-learn dot linear model. So it is falls under linear model. So import logistic regression. Okay. Then I also need accuracy score. So from scikit-learn dot metrics input accuracy score. So accuracy score is the metrics for this one, your classification problem statement. Okay, so let me import all of them. Okay, so it is giving me one error. So okay, import pandas as pd, it would be, sorry. Yeah. Okay, now see, everything is imported perfectly. Now we have to load the data. So to load the data, how I can load guys, just call pandas.read. It's a CSV file. You can see the extension is a CSV file. So let's call read CSV. Inside that you have to give the location. Just try to copy the path, and here just try to paste it. Okay, now let's store inside a variable. I'm going to name it as it's a sonar underscore data. Okay, now let me load it. Now if I show you the sonar data dot head, so guys, you can see this is the data, but here you can see this column name is coming okay, it's a number. So what I will do, I will try to replace this number with just like 1 2 3 4 like that. So for this you have to mention this parameter header is equal to none. So now if I show you, see now actually it is now readable. Okay, now you can see it is having 60 column. Okay, 60 column, and the last column is the target column. So here R means it's a rock, and you will see M means it's a mine. Okay, and these are some sensor data actually I have. So based on that we have to predict that particular let's say object. Okay, so now if you want to see the like how many let's say record you have here, so you can simply write this code. So sonar data dot shape, so this will print the number of record you have. So here you have 208 rows and 68 61 actually columns, because it is starting from 0, that's why 61 columns are there. Okay, and if you want to see the statistical analysis, so you can just write describe sonar data dot describe. You can see the mean, standard deviation, okay, 25% percentile, 50, 75, and max. So I think you already know. Okay, in statistics you have already learned these are the parameter. Fine. Now if you want to see like how many let's say rock and how many mine example you have in the entire data, so you can see that, just write sonar data. So the number of column name is, it's a 60 maybe, let me show you. Yeah, 60. So let's give 60 here. Okay, 60 is the label. Okay, now here I will just apply value counts, value underscore counts. So it should, so here you can see it is showing mine you have 111 and rock you have 97. Okay, so it's not imbalanced data, it's completely fine. So here M means it's a mine, R means it's a rock, guys. Okay, remember. Now we have to separate out our X features and Y features. So instead of 60, all of the data is my X and 60 is my Y. Okay, so how to separate? So you can write X is equal to sonar data dot drop. Which column you have to drop? You can specify column. I want to drop 60 column, 60 number column. Okay, and axis, it's a column, I will give 0. Axis is equal to, sorry, axis is equal to 1. Okay, so this will give me the X, and if I want to take the Y, so Y is equal to sonar I'll take the 60. Okay, this one. Now if I execute, now if I show you my X, so this is my X, that means all the sensor data, and this is my Y, that means my target column. Okay, now we can apply the test split operation. So this is the code you can apply. So here I'm using test split function. Inside that I'm giving my X data and Y data, and test size I'm specifying. I need actually 10% data for my testing and 90% data for my training example. Okay, and stratify Y I have given because you can see this is the it's an English character. Okay, so whenever you will give this data to the model, so it will convert to the number. Okay, then random state is equal to 1, and it will store your X data, Y test data, sorry, X train data, Y X train test data, Y train data, and Y test data. So let me execute. Now if you want to see the shape, so you can see this is your original shape, and this is your training example. You have 187 example, and in test you have 21 example only. Okay, now we can train the model. So just write model is equal to I can specify my logistic regression model. Inside that I will give my X train and Y underscore train data, and now we'll feed the data. Okay, so model dot feed X train and Y train. Okay, now if I fit, okay, there is a error actually I'm getting. Okay, sorry guys, so the thing is like here you don't need to pass the data. Okay, so this is just a model initialization you are doing. Now here you are feeding the data. Now I think it should work. See, model got trained. Okay, now let's do the model evaluation. Okay, so what is the accuracy score you got after training the model? So what I can do, I can just first of all calculate the accuracy on the training data. So model.predict x train. Okay, I'm giving the x train because I want to see the accuracy on the training data. And you will see that training data accuracy would be always high because that same data we have used for the training. And to calculate the accuracy, guys, here you have to pass in the accuracy score function. So here I'm giving my prediction and I'm giving my original y train. Okay, now this will give you the accuracy. So let me print the accuracy here. Now see, here you are getting 83% accuracy. Okay, fine. Now you don't need to rely on the training accuracy, you also need to see the testing accuracy. Okay, if testing accuracy is good, then you can select the model. So let's calculate the accuracy on test data right now. So here I'm giving the test data and here I'm getting the prediction, and now I'll pass the test score inside my accuracy score. Okay, this one. So here I'm giving my prediction and my original y test. Okay, and this will give you, and this will give you your testing score. So first of all, let me execute this line, then I will paste this particular code, and this is my testing accuracy I'm getting. So it's almost 80%. So see guys, if you want, you can also perform some feature engineering on top of it to improve the accuracy. Okay, but I think this accuracy is also fine. Okay, you can use it. Now let's do one prediction on top of my new data. Okay, so what I will do, I will make a new data. So this is my input data, guys, I prepared. You can see this is the entire input data. So all the sensors I have collected, okay, one by one, all the 60 data. You can see it is having actually 60 actually record here. Okay, now first of all, we have to convert this data to the NumPy array. So you can see I'm converting to the NumPy array. Then after that, I have to reshape it. Okay, because here I only have one record, that's why I have to give 1 minus 1. Okay, so it will reshape the data. Then after that, I will pass it to my model. So here you can see model.predict, and here I'm passing the data. Now it will give me the prediction. Now it's predicting m. Okay, if it is m, so I can write a condition here. So this is the condition. If prediction is equal to r, object is rock. If prediction is equal to, let's say, m, it's a mine. Okay, now if I execute, so it's a mine. Okay, because it is predicting m. So yes guys, we have completed this project. Now if you want, you can also improve the project. You can also add some more feature engineering technique, and if you want to convert it to the end-to-end pipeline, guys, I already shared the template with you. The same template you can use. Okay, I'm not going to show you again and again the same implementation, and you can deploy this project also. Okay, and I also showed you how we can create the user interface of your application. If you want, you can also create it. So yes guys, this is the project. In the next video, we'll be creating another project. Okay, so that's how you will be getting lots of project idea, and this project you can mention in your resume as well. Okay, so with that guys, thank you so much for watching this video, and I will see you next time.